Present. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon to all of you. So we will start our class this week 5. So today I'll introduce you second chapter. So we have done first chapter concerning the linear algebraic equation. Okay, so we have seen several methods, direct, indirect, okay, LU methods, Jacobian, Gauss, elimination, right? So now, today we will continue with second chapter, which is nonlinear. Okay, so linear, nonlinear. Okay, so the objective is the same. Okay, the aim is to, of course, to solve the equation and to find the root or the x. Okay, the root of the problem, the zero, the x. Okay, this to solve the solution. Okay. Okay, next. Okay, there are two methods that I'm going to introduce for nonlinear. So the first one is bisection method. Okay, where it is also called as Bolzano method, but usually we use the name bisection method, and can be called interval halving technique as well. Okay, interval halving technique. Halving, half means separuh, half. So we divide. We do the iteration by dividing. By choosing an interval and dividing the interval into half, into two. So we find the mid, okay, the medium point, and then we continue, etc. until we achieve the solution. Okay. So the method is quite simple and straightforward. Okay, given a bracketed root, means the interval just now I mentioned. So we choose the interval, we make assumption of lower and upper value of the root, we assume, and so it's like an interval, a bracket, and then we continue the method repeatedly, half the interval. Okay, so we search for the medium, okay, the middle point of the interval, lower and upper, the middle point. So we make half of the interval while continuing to bracket the root, and it will converge on the solution. Okay, and we continue the iteration, the procedure, until we converge to the assumed solution. Okay, to the solution that we want. Okay, so the steps. Okay, the procedure for bisection method. I think you guys are already familiar with the method. I think you have done maybe in your foundation or SPM. Okay. So the step one is, okay, ada lagi nak masuk. Okay, the step one is to choose the interval. Okay, we choose the interval. So here we call the interval XL and SU. So SL is the lower interval X, and SU is the upper interval. Okay, we assume. Okay, XL here and SU. So non-linear, see here non-linear, because linear is like a straight line, direct, right? So here we have a non-linear equation, non-linear algebra. So we have to solve. Means, what do you mean when we solve a non-linear algebra equation? Means that we are trying to find the root of the equation, or the solution where fx, the function equation, is 0. Okay, we try to find x where fx is 0, function is 0, equation is 0. Okay. Okay. So we make two guesses, SL and SU. Okay. We choose SL and SU such that, okay, they require that we need to the condition. Okay, the required condition is that fx, okay, fsl and fxu multiply is below than 0, which means negative. Okay, so we choose SL and XU such that fxl means the function of SL and a function of SU is such that they are both when multiply is negative, means that we have to search for XL and SU where the function FSL and FSU is in different what do you say? This different sign, negative and positive. So that's why FSL multiply FSU is negative. Okay, you want to find different sign of SL and SU. No, FSL and FSU, so that we are sure that the equation, the function will cross the line where fx is 0. Okay. Otherwise, if FSL and FSU is the same sign, has the same sign, positive positive or negative negative, so the line, okay, the chosen interval won't cross the line where fs is 0. Okay, so here we choose, for example, here, so FSL is negative and FSU is positive. So we are sure that the line, the function will intersect with this axis x, okay, or fx equals to 0 between the interval. Okay. On, in other words, fx change signs between SL and SU, change sign, okay, negative, positive. So that is the condition of choosing SL and SU. Okay, next, step 2, estimate the root. So as I've said just now, we make half, okay, interval half. Okay, estimate the root XM, medium or mid, okay, sorry, medium. The midpoint, okay, not medium, midpoint of the SL and SU, okay, of the equation. So we assume that this midpoint that we choose is the solution. We assume, okay, and then we iterate, okay, continue, okay. So XM, we choose SM where SL plus SU divided by 2 half, okay, so we assume that is SM, okay. And then step 3, okay, now we have to check, okay, whether the SM that we choose, okay, that we have calculated is the solution or not, okay. Is it the solution, the root of the equation? Okay, so how to check it? So the first condition is that if this is where you have to when you want to program, okay, later on in your assignment, so you must add this condition. Okay, so first condition is if FXL, okay, FSL multiply times FXM, okay, is negative, then means that FSL and FSM change signs, right? Okay, then the root lies between SL and SM. Here, we assume, okay, if the sign of this FSL and FSM is negative, mean opposite, change sign, so we assume, okay, the root must lie between SL and SM. So then before we proceed to another round of calculation, if this is true, okay, so we before we proceed, then we have to assume again that SL is still SL, but XU for another round is now SM. Okay. So if the condition of this is correct, if it's correct, then SL will maintain as SL, but the upper interval will become SM. So now that the interval will become smaller. Okay, we will converge slowly to the solution that we want. We will converge to the solution that we are searching for. Okay, so that's why the interval earlier initially is SL and SU. Now, if both of SL and SM is different sign, so we assume SM is now the XU. So we cut this part, so only this part. So we are approaching the solution, we are converging the solution, if the condition is met. Otherwise, okay, if FSL multiply with FSM, if is positive, the same sign, whether both are negatives or both are positive, same sign, then the root lies, okay, which is in exactly like in this graphic graph. Okay, if FSM positive, right? They have the same value negative, so multiply both become positive. Then the root must lie between this, which is like in the graphic here. Okay, this is more clear, right? So the root must lie between SM and SU instead of here. Okay, so if this condition is met, is correct, then before we proceed to another round, to another loop, then SL now change to SM. Okay, SM will take the value of SL, and SM will be the lower value, and XU will maintain as XU. And then we continue next round, okay, next loop, to search for the correct solution, this value that we want. Okay, we converge. Okay, otherwise another solution, another condition is that if FSL multiplied with FSM equals to 0. So what does it mean? This means that the root is SM. Okay, means that we have found the root. Okay, the solution. Okay, because FSL we know this is not 0. We already see the condition earlier. So must be FSM which is 0. So FSM 0 means that we have found the root. Okay, the right root SM. Okay, so we stop the algorithm, stop the programming. Okay. So this is example of the steps. If you can also write if you use, instead of you don't want to use FSL, you can use FSU. So the same condition. You still you put here if FSU multiply with FSM negative, then SU and the root lies between SU and SM. Then SL is SM and SU is SU. Okay, so you just have to change it a bit. Okay, so it means that you can you not only use FSL, you can also use FSU. Okay, and then check back your condition. Okay, I hope you understand that. Okay, next. So the new estimation value meet. Okay, we have the next round. Okay, once that we have changed, or now for example we take this one. Okay, like this graphic. So this graphic, this graph agrees with this second condition, right? The second condition agrees with this graph. Okay, so now SL is SM and SU is SU. Okay, maintain. So we have to calculate again the new SM, the new midpoint. Okay, so SL here is actually SM the first round. Okay, so SU, so divide by 2. So we are approaching the solution, and then we continue. The new estimation continue until we reach the convergence. Okay, so in order for to stop, okay, for the program, we to ask the program to stop. Okay, we have to write an approximate error. Okay, we insert we apply as an error relative. How do we calculate this error? Is the absolute value. Okay, absolute value of the difference between the new, the previous, and the current the current and the previous SM, okay, that we have found, over the new SM, the current SM, multiply to get the percentage. Okay, so this is previous, this is current, depends. So if you have done 5 iterations, 5 round, okay, so this X new will be the 5th XM, and this XO will be the 4th SM previous round. Okay, until you get for example, if you set 0.5%, okay, 5%, 1%, so you must make sure that you have this error, the difference between the previous and the current estimation of root lower than the percentage that you have set. So then you stop. Okay, we assume that the solution have converged. Okay, we have got the, maybe not the exact solution, but the most possible solution, the most approach. Okay, solution. Okay. Okay, what else? Step 5. Okay, so check if absolute, relative, approximate error is less than pre-specified. Okay, this one I have mentioned. So check whether the difference just now, the error percentage is less than what you have set. Okay, or if maximum number of iteration is reached. Okay, otherwise sometimes instead of by setting the percentage of error, sometimes we set the number of maximum iterations. So means that we don't know whether the error is 10% or 1% or 0.01%. Whatever the error is, if we set the maximum number of iteration. Example, we set the maximum number of iteration 50%, 50 or 20 until until n. N equals to 20, 10 or something like that, and then we stop. So we don't care about the error. Okay, we set the maximum number of iterations. So it depends. What condition do you want to set? Okay. So if yes, then stop. If the condition is met, okay. If the absolute error is less than what you have said, so you stop. If no, then we have to continue back to step 2 just now. Okay, use the upper lower limit. Okay, so that is the how you do the bisection method. Okay, so advantage, of course there are advantage and disadvantage. Okay, so the advantage, always convergent. Okay, the approach, okay, the process always will be convergent, inshallah. Okay, the root bracket gets half with each iteration guarantee. Okay, because we calculate manually. Okay, and disadvantage, slow convergence. Okay, if one of the initial guess is close to the root, the convergence is slower. Okay, because we already close to the root, and then we make half, so it's getting slower. Okay, so there are advantage and disadvantage. Okay, and another drawbacks. Okay, drawbacks for certain equation, it's non-linear, but we can't use bisection method, even though this equation are non-linear algebraic equation. Okay, for example, like this one, the quadratic equation. Okay, if a function fx is such that it just touch the x-axis, it will be unable to find the lower and upper guess. Okay, so for example, fx is x square. Okay, so the graph for, the graph for x square. Okay, we touch 0 only at this one point. Okay, fx when x0, fx equals to 0. So it doesn't have two negative value like fsl, fsu just now that we can find the root in the middle, right? So you only touch once, fx once. So this function we cannot use, we cannot apply the bisection method. Okay, only touch the x-axis at one point. We must need we need at least two different signs. Okay. Next, okay. This function, okay, fs 1 over x. Okay, so we have this graph for 1 over x. So this 1 over x, the function change signs. Okay, this time the function change signs. So because this one only positive, right? This one it change sign. We have negative and positive value. It's just that the root doesn't exist. Okay, or the root is plus infinity or minus infinity. So the root doesn't exist. So we can't use the bisection method to solve this equation. Okay, because it doesn't really touch 0 until infinity. Okay. Okay. Okay, for bisection method, everyone okay? Bisection method?
Okay,
I think you already know. Okay? Okay. So second one is the Newton-Raphson method, also known as Newton's method. Okay, simply. Okay, so this method, okay, given an initial guess of the root x0, initial value of x, okay, we assume an initial value of x. Newton-Raphson method use information about the function and its derivative at that point to find a better guess of the root. Okay, so basically we have to apply derivative. Okay, we use derivation form. Okay, assumptions. To apply this Newton-Raphson method, there are two assumptions. Okay, fx is continuous and first derivative is known. Okay, fs is continuous means that even for this function, this is not continuous. Okay, or maybe we can say this is continuous for x positive, continuous for x below 0. Okay, but it's not continuous at x0. Exactly, this function is not continuous at x0. But to apply the Newton-Raphson method, fs is, we have to assume fs is continuous, okay? Or continuous between a certain interval, we define it, okay? And first derivative is known, means that we can calculate the derivative, okay? An initial guess x0 such that f prime x0 is not 0, different than 0 is given, okay? So we have an assumption of x0. x0 is given such that this f prime, this derivation of fs at point x0 is not 0. What does it mean? Okay, a derivation of a function of a derivation. What does it mean for function of derivation? In graphic, okay, it means is like a slope, right? A derivation. A tangent, like, okay, a derivation is a derivation of a function is like a tangent of the function, okay? So we choose as x0 such that the tangent at point x0 is not 0. What does it mean? It means that the slope is not like totally vertical or totally horizontal, because vertical is infinity. Okay, the slope, the tangent is not horizontal. If the slope, the tangent is horizontal, means that the derivative is 0. You know that, right? Okay. If the slope, the tangent to a function, if is 0, it means that the derivative at that point is 0. So we don't want that. Okay. So we choose x0 such that f prime s is not 0. Why? Because we want to avoid this one, like this one. Okay, this one, the f prime, if x0, x initial 0 is 0, yeah, which is at this point 0. This the tangent to this line, okay, this function. Okay, if you do the derivation, okay, and we put the point x at 0 to this function, the tangent, okay, is 0, horizontal, right? So we want to avoid this, okay? So, okay, see graphic, okay? Okay, Newton-Raphson method. Okay, a convenient method for functions whose derivatives can be evaluated analytically, okay? Means that you can analyze it, okay? It may not be convenient for functions whose derivatives cannot be evaluated analytically. So, a graphical depiction of the Newton-Raphson method, okay? So, this is the graphic version, okay, to explain clearly. If the initial guess at the root is xi, okay, if we assume the initial root, we assume xi, okay, then a tangent to the function of xi, that is f prime si. So the tangent, the slope, okay, the slope, this black line is extrapolated down to the x-axis, extrapolated, tarik dia kan, okay, down to the x-axis to provide an estimate of the root at xi plus 1, okay. So this Newton-Raphson method actually, how does it calculate? Okay, we choose xi. Okay, and then we do the derivation of we calculate the derivation at point f prime si, right? Okay, and then it's like we do the extrapolation, okay, to find the next, okay, the next si, the next guess, okay, of the root, which is si plus 1. So it is like a linear line, okay. Okay, so we will approach, okay, the solution by using this method, okay. So okay, this is the function, this is the equation. Okay, based on Taylor series expansion, okay, I'm not sure if you have seen this formula, but it's quite this formula is quite common, okay, in analysis, okay, numerical analysis, or in mathematical algebra. So this is what do we call Taylor series expansion. Okay, this is Taylor series expansion. So it's already proven. Okay. So we have this definition. Okay, fxi at point I plus 1, okay, is equal to fsi plus f prime si and the interval of x plus f prime prime, second order and third order, etc. Actually, we can continue. If you want to continue, this one will become f prime prime prime, okay, the third order si and the interval s power of 3 to the 3 factorial, and then continue. It depends on the how many order do we want, second order, fourth, fifth order. But normally, this, okay, the higher order, the higher degree, the higher order that we have, the higher order will become, will approach to 0. Okay, actually this value depends on the function. Okay, so the higher order will converge to 0. So there's so sometimes we neglige, okay, we neglige the higher order values. Okay, depends. Okay, so so we only take for Newton-Raphson method, we only take until this part, okay, until the second term of Taylor series expansion. Okay, so Taylor series expansion is long. Okay, depends how many higher degree of order you want. Okay, but for Newton-Raphson, we'll take this part. Okay, so the root is the value of xi plus 1. Okay, so we assume the root is si plus 1 when when the function of si plus 1 is 0. Okay, we assume if we the root is x, so the function must be 0. Okay, so we rearrange this part, rearrange this, and then we have this. Okay, just rearrange this part, and then we get this. It becomes 0 here over the left hand side. So we just take over it to the right hand side, and we get this equation. So and change here, rearrange again. So this is the Newton-Raphson formula that we are going to use. Okay, so we are going to solve for si plus 1. Okay, we will try to search this one. Okay, so we have si that we assume. So once we have si, we can calculate fsi and the derivation, if derivation. So that's why we need to have the assumption just now. The first derivative must exist. Okay, otherwise this value will be 0 and infinity. So we can't solve it. Okay, so the derivation must exist. Okay. So this is Newton's method. So if you do the programming, okay, in MATLAB or Python, etc. So this is how you write the program. Okay, so given fs, f prime s as 0. Okay, so by assuming that f prime s 0 is not null, it's not 0. Okay, so for I, we do the iteration. For I from 0 until n, we decide the value of n. We do this. We apply the Newton's method. So how do we write it? Function fx, for this is example, okay? So example, we have the function x cubed minus 3x power of 2 plus 1. So we do the derivation. So f prime, fp, we have 3x power of 2 minus 6x. So the derivation of this function. Okay, and then we do the MATLAB program. So we assume x initially equals to 4, x0 equal to 4, and then we do until iteration 5 iteration. Okay. Okay, so this the drawback. Okay, the drawback of the Newton's method. If the initial guess of the root is far from the root, the method may not converge. So we have to correctly or not correct, wisely assume the initial guess of the root. Okay, otherwise you will take longer time to converge. Okay. Okay. This is example where you have multiple roots. Okay. Okay, so this one, okay, so the fx s3, so you have 3 solution. If you apply the complex problem, okay, you have minus I, the complex solution. This one you have the same roots at -1. Lagi, the sum of the root is going away from, okay, this is okay. This is an example where if we doesn't choose the wisely the initial, so we tends to not approaching the solution, but we tend to going away, okay, more further away from the root. Okay, this is some of the problem if you use Newton's method. Instead of converging to the solution, we are going further more away. Okay. Another thing, flat spot. Okay, this is just a drawback. Okay, this one, if the route that we choose keep making algorithm cycles, mean that we rotate, okay, between the same interval. We keep rotating between the same interval. That's why sometimes instead of setting the criteria for stop, instead of setting the percentage of error, we set the criteria as the number of maximum iteration. Because, for example, like this, okay, for example, like this equation, if we set the stopping criteria is less than 10%, less than 5%, we will always, if we get the error more than 10%, always get the same error more than 10%. So we keep the program keep running. Okay. So for this type of problem, maybe it is wiser to set number of maximum iterations so that it will stop. Okay. But and we take whatever the approach, the solution, the last solution given. Okay. Okay, so I have 2 examples of exercise. Okay, one by using dissection and another one by using Newton-Raphson. Okay, so we try to do this one. Okay, 240. So the first one, use bisection to solve the drag coefficient C needed for parachutist of mass M 68.1 kilogram to the parachutist the weight is the mass is 68.1 to have a velocity of 40 meter per second after free falling for a time t equals t for the period 10 seconds. Okay, free falling 10 seconds of velocity 40 meter per second. So the gravity 9.81. Okay, so we estimate the root. Okay, by using bisection method, we estimate the roots, the lower and upper x, 12 and 16. Okay, actually this one you can draw a graph and then you try to estimate. Okay, when you draw the graph at each point of x, and you can see that when fx equals 0, the s lies between which interval. So we assume between 12 and 16. Okay, so this is the function. Okay, this is the function. Fc equals to gm. Okay, g gravity, m mass, over C, the direct coefficient. So C is the root that we want to search here. Okay, I should have put this is C. Okay, so C lies between 12 and 16. So 1 over 1 minus 1 minus exponential. Okay. Okay, actually, yeah, there's a bracket here. Should be a bracket here. So so you won't get confused. Okay. Okay. So GM over C multiplied with 1 minus exponential minus C over MT. Okay, minus V, velocity. Okay, so try to do this one. Okay, bisection method and see how much value direct coefficient that you get. Okay, so FC GMC. So the equation is like this: 1 minus exponential C over M P, okay, minus V, velocity. Okay, minus C over M P. Okay, so G 9.81, M mass 68.1, C that we have to search, M again T 10 second, and minus V 40 meter per second. So by using bisection method, okay, so first we have to do the first step, X equal to 12, okay, so or C here, C equal to 12. So we calculate the value F where C is equal to 12, and another one we calculate the value of F where C equals to 16. So that is the lower upper value. Okay. Calculate that one. F means F12 and F16. At the same time, you have to, okay, 12, 16, the midpoint is 14. So F14 also. F12, F14, and F16. Okay, and then you see the sign. Okay, F12 multiplied with F14, whether the sign is negative or positive. Okay, see the condition. We try to do one round first, and see how much C the C drag coefficient that we have. Okay, ke everyone? Harsha, okay? Semua okay? Any questions?
Okay, Doktor, tengah calculate.
Okay, so calculate F12, F14, F16. and then see the sign. Which one, whether F12 and F14 or F14 and F16 that you have a different sign. Nah. Okay, continue, just continue. Okay. Okay. So here you can see which one will be negative, right? So it will be between 14 and 16 instead of between 12 and 14, right? Okay. So tak tahu kalau cepat sangat. But next round means that you have to divide 14 and 16. Search the half. So the half is 15. Okay. So the second round of SM will be 15. And then continue. Search for F15. No, F15. Yeah. Okay. Yeah. I have to change place. Battery nak habis. Okay. Okay. So continue for next round. Between 14 and 16. So SM is 15. So you have to search for F15. Okay. The root is 14.8. Okay. Okay, short estimate. The root is 14.8. So F15 negative. So the root must, okay, so second round we have found that F15 is negative. So means that the root will lie between 14 and 15, right? Because F14 just now is positive. So the root will lie between 14 and 15. So the, for example, the solution that Kisha gave may be correct, okay? Because the solution is between 14 and 15. Okay. Okay, so I think everyone, I think you guys have understand, okay? Got the understand the approach, the step, the procedure. Okay, so we can stop at second round. Okay, 15 just now. Okay, 14, 15. So in the middle will be 14.5. Okay, so we can start at 14.5. Or if you want to divide more, you can continue another round. Okay, so we can stop for manually. You can stop here. Okay, second or third round. Or third round better. Okay. Semua orang, everyone okay? We will proceed with the next questions.
Okay, doctor.
Okay. Just checking.
So doctor, we just need to find the values from between 12 to 16.
Yes, we assume the root. Okay, the answer is between 12 and 16 now. Only one solution. Okay.
Okay. Noted. Thank you, doctor.
Okay. Next. Okay, next Newton-Raphson method. Okay. Okay, use the Newton-Raphson method to estimate the root of fx. Okay, so fx, the function is exponential minus x and minus x, employing an initial guess of x0, 0. So we assume the initial value of x is 0. Okay, so by using the Newton-Raphson method, okay, so go back to the Newton-Raphson method equation. Okay, this one. Okay, we will apply this. So first, okay, x0 is so si x0 the first round. So x0 is 0. Fx 0. So put inside the substitute in the equation exponential minus x just now, right? So exponential minus x, exponential 0 is 1. So 1 minus 0 is 1. So this value, the first round will be 1 over, okay, so the derivation, okay, the derivation, you derive and you differentiate and you substitute with the value at 0 initially. So, and then calculate x1, that is the first round for x1. Okay, did I give a criteria for stop or no? Okay, I think we stop at error 5%. Yeah? We try to do that. Okay, so formula. Okay, so the derivation of this f prime x is minus exponential minus x, right? And minus 1. Tak boleh tulis dekat ini. Sekejap. Okay. So f prime x, the function will be minus exponential minus x, okay, minus 1, okay. So for this first round, x1 will be x0, which is 0, minus fx here, okay, fx here is exponential 0, which is 1, minus 0, so 1, over this one, okay, so x0 just now, so this is still 1, minus 1, minus 1, minus 1, minus 1, minus 2, so 2 minus minus, okay, so 0.5, x1 will be 0.5. Okay. And then second round, x2. Okay, if you want to calculate the error, okay, we check the error. But actually the error, okay. Error just now, the equation for error. So the absolute value of x1, which is 0.5, minus 0, the initial, over 0.5. Right, like this, and percentage. Okay, so this one is 100%, so still big. Okay, the error. So next, for calculate for x2 and then calculate the error. Okay. So what is your x2? Okay. 0.5663, okay. So the error becomes smaller. Okay. If you want to continue another round. Okay, so the second round, x2 will be 0.5663, around that. So you calculate the error, 0.563 minus 0.5, x1 just now, over 0.563. So the percentage is less than 5. Okay, it's getting 11.7%. Okay, the third round I think will be less than 5%. Keep going. Okay. So x3, I think last one x3. Now, okay, maybe check your derivation. So last round x3, how much? 0.5 what? So we see here by using Newton-Raphson method, the calculation is more faster, okay? So we just use the formula instead of just now in the big section we have to check signs, etc. So did you guys get x3? X3, masih senyap ni okey ke? Next week test. Okay, so next week will be our test, our first test, and the only test. Okay. So how much x3? 0.5, around 0.567. 0.567, around that. Okay, and the error will be less than 5%. Okay. Okay, so we can stop there at the third round, third iteration. Okay. Oh, ada lagi masuk. Okay, so we finish. Okay, finish this second chapter. So only two I introduced only two method. So if you look at some reference books, there are a lot of several other methods, linear, non-linear, right? So you see here in our course, I only choose several methods to introduce to you, not all, because otherwise it will be too long. Okay, so I just choose several that I think will be most possible to use. Okay. Okay, next I will assignment. Okay, so remember you guys have a second assignment. So this one. Okay. But don't worry, for this second assignment, we'll give deadline in 3 weeks. Okay? Because I know next week you guys have tests. Okay. So this one, wait, loading. Sorry ya, anak balik sekolah bising sikit. Okay. Okay, so second assignment, you are working for a company that makes floats for ABC Commerce. Commerce is actually a toilet flush. Okay. You are asked to find the distance to which the ball will get submerged when floating in water. Submerged, tenggelam, drown. Okay, in the water. Drown or in the water. So you have to find the distance x, okay, which the ball will get submerged, okay, in the water. Okay. Okay. Okay, so okay, the equation that gives the depth of x, okay, the x here to which the ball is submerged underwater is given by, so this is the equation of x, fx. So we have x cubed minus 0.165 x squared plus 3.993 10 power of minus 4. So use the bisection method. I want you to use bisection method, okay, of finding roots of equations to find the depth x to which the ball is submerged underwater. Conduct iterations to estimate the root of the above equation until the error of estimation is less than 5%. So we set the error less than 5%. Okay, so we have to do the programming, okay? Because Newton method, this is quite simple, the problem. So if you use Newton method, you just calculate. So I want you to use bisection method so that you at least you can learn to program the condition. If this is, then what to do, okay? Okay, so as usual, the instructions are the same, okay, as the previous assignment. So the assignment is to be done in pair 3 to 4 persons in each group. The total marks will be 10 marks. Submit your programming code with the answer, okay, the same as assignment 1. Record less than 10 seconds, etc. Okay. Email your coding code to me. So due date is 10th May. So in 3 weeks, okay, extra 1 week because you have test next week. Okay, but you can start, okay, whenever you want. So except that I give extra 1 week, 3 weeks. So this is in, I know this is in between in the middle of the sem break, right? And just a few days before Hari Raya. So I think it's better that I give deadline before Hari Raya than after Hari Raya, because otherwise anyway you won't be working, do your assignment during Hari Raya, right? So whether rentas negeri tak rentas negeri lah, rasanya memang takkan kerja pun Hari Raya. Okay, so so due date just before Hari Raya, so at least you settle so that you can Raya. Okay. Okay, so 10 May in 3 weeks. Okay. So I think this assignment is easier. Plus it's easy because you already know what to do, the programming. Okay. So let's see lah. Okay. So I start. Okay. Last before we leave, of course, attendance. Okay. So I stop the recording.